Hi, welcome. In this video, we'll solve problem counting bits asked by companies like Amazon, Microsoft, Facebook, Google, and some others. Now let's solve one more problem on bit manipulation. Okay. Let's check out this problem, counting bits. So here we have given an integer n, written an array and an answer of length n plus 1. So we need to return an array whose length will be n plus 1. Such that for each I, that is I is starting from 0 to n, that means n is also included, we need to return number of ones in the binary representation of I. So basically they are asking for number of set bits. Okay. So since like here you can take this example first, or let's start with this one. We have n is equals to 2. So I will start from 0, 1, 2. And what are the binary representation of 0, 1, 2? So basically for 0 it is 0, for 1 it is 1, for 2 it is 1, 0. Okay. So how many set bits we have? So at the 0 we have 0 basically, right? At 1 we have 1, and here we have also 1. So my output will be this array, right? Basically. So my output is like this. I am going till index 2, means till index n. So 0, 1, 1. Similarly, when n is equals to 5, I will start from 0, 1, 2, 3, 4, 5, right? And what are the number of bits available for 0? That is 0. What are the number of bits for 1? That is 1. For 2, that is 1, 0. Binary representation. For 3, it is 1, 1. For 4, it is, I guess, 1, 0, 0. And 5, it is 1, 0, 1. Bits, if I say number of set bits, so set bits for 0, 0, for 1, 1, for 2, 1, for 3, 2, for 4, 1, for 5, 2, right? And this will be my array for 5, 2. Why I'm writing 5, it will be 2. So yes, that will be my array and I will simply return it. Okay. So that will be my answer. So how we can solve this? So if you have solved my last problem where we have find out number of set bits of a particular number. So suppose if n is equals to 5, what will be the number of set bits? That means 2 will be the set bits, right? So we know how to count individual, right? We know how to count individual. We have already seen it. So let me see that. Let's see. Let's start with taking one example. N is equals to 5. So basically what we need to do, I'm starting this 0, 1, 2, 3, 4, 5. And what I need to do, I need to simply return number of set bits, right? So we have already solved that if you have solved that problem, number of 1 bits, number of 1 bits. So basically we are counting, or basically we are finding number of 1 bits of a particular n. Suppose if n is equals to 5, what will the number of 1 bits? That will be 2, right? So similarly, we can find for each bit, right? We can find for 0, 1, 2, 3, 4, 5, right? That is also one possible way. But remember that what was the time complexity of finding number of 1 bits? That was the time complexity of log n, right? Basically, we were doing right shift operator at that time, right? So log n will be the time, and here if I'm funding for all the n's, right? So it will run for n times. So the total time complexity will be n log n. Yes. So for this approach, the time complexity will be big of n log n. Okay. And it will be exactly same as our previous. Let me give you a pseudo code of it. So basically what I will do, I will simply start from, suppose I is equals to 0, and I will go till less than equals to n, because n is also included, I plus plus, right? And what I will suppose, I am taking one result array. So let result, okay. And in my result array, what I will do, I will simply say result of I will be basically, I can write the function, right? Number of 1 bits that we have solved, right? Or count bits, any function. Basically, I will simply store the count bits value. So count bits of I, right, will be my answer. I will simply store it, and yeah, that's this. I will return it. I will return result then. So here for count bits, the time complexity will be log n, and this is running for n times, so it will become n log n. This is the one approach. Okay. Now what will be the second approach? Let me write it here. That is one approach. That is first we can solve it by this. Now there was one follow-up questions also, like if you have seen Leetcode, there is one follow-up question that can you come up with more optimized version of it, right? Can we reduce the time complexity of it? So let's see, let's try to find some patterns, okay, and then we eventually solve it. So if I take 0, starting from 0, then 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10, right? And for 0, what is the binary representation? That is 0 only. For 1, it is 1. For 2, it is 1, 0. For 3, it is 1, 1. For 4, it is 1, 0, 0. For 5, 1, 0, 1. For 6, 1, 1, 0. 7, I guess 1, 1, 1. For 8, I guess 1, 0, 0. Yes. For 9, again 1001, I guess. And for 10, we have 1010. Right. And if I count the number of bits here, so we have 0, 1. Here we have 1. Here we have 2, 1, 2, 2, 3, 1, 2, 2. Okay. Now let's try to find some pattern, right? So we are getting only single 0 here, right? So that is a different from our pattern. Okay. So for 0, the answer will be 0. Right? And we here we are getting 1, 1, 1, 1, right? So you can see whenever there is 2's power, right? 2's power 8, 2's power 4, and 2's power 2, the bit value is only 1, right? So set bits will be 1 here. Okay, here, one observation I can see here. And let's figure out one more observations. Can you see that we have this 8, then we have 4, then we have 2. So what I am just basically telling you that 8, the answer of 8 is 1 and 8 by 2 is 4. So answer is same for 4 and 4 by 2 is 2. So answer is same for 2 as well, and 2 by 2 is 1. Answer is same for that one, right? So for this one, this we have solved it, right? How we are getting 1 basically. Okay. And let's see, is it the same pattern in the others, right? So let's see, we have 6 and 6 by 2, that is 3. So yes, for 6, the answer is 2, and 6 by 2, that is 3. And the answer is again 2, that is same, right? So I guess for 12, the answer should be same, right? Let's suppose, let me write two more binary representation. So for 11, the answer will be 0, 1, 0, 1, 1. And for 12, the binary representation will be 0, 1, 1, 0, 0. So yes, here we have 3 and here we have 2. So yes, you can see 12, 6. Let me do it with blue pen. 12, 6 and 3 has same values, right? Same binary representation, that is 2, 2, 2. Okay. That means if we have solved for the first 4 digits, we can easily answer the other digits, right? If they are basically doubled of it. Okay. Let's see for the odd ones now. So suppose if I am taking 11, okay. So 11, we have an answer of 3. 11 by 2, what it will be? If I take the floor value, it will be 5. It will be 5. And what is the value of 5? That is 2. So basically, if that is an odd, right, I need to get 2 plus 1 to find the value. So basically here, see, let's understand it again, right? I need to find for 11. What I will do? I will do 11 by 2 And see, 11 is odd. Okay, especially for odd. Okay, this is for even case, right? For even case, if you want to find for 8, if you know the value of 4, you can simply return the same. If you are finding for 6, if you know the value of 3, you can simply return the same. For 11, because 11 is odd, if you divide it, you will get 5. So whatever the binary set bits of 5, that is 5 is 2, you need to add plus 1, that it will be 3. Okay, let's see for other cases. Suppose I want to find for 9. So I will find for 9 by 2, that is 4. And whatever the set bits of 4, I will simply add 1. So 4 we have 1. I will simply add 1. 1 plus 1, 2. And you can see 9 we have 2. Okay, let's take 7. So for 7, 7 is odd. 7 by 2, I will find that is floor value is 3. And what is the value of 3? That is 2. I will simply do 2 plus 1, that is 3. And here we are getting an answer 3. Right? So now it is very simple. Our by simply observations. Again, these are all observations we can categorize into two parts: even case and odd case. Right? Even case and odd case. So what we can do basically, see, if that is an even case, first of all, I need to first initialize with 0. So I will first solve for 0, then I will fill with 1. So basically these two values will be there. For 0 it will be 0, for 1 it will be 1. Right? Now if it is an even case, so whatever the value is, suppose n is equals to 2, what I will do, I will simply divide by 2, right? And I am getting 1. So whatever the 1 has the bits, the 2 will have the same bits. So you can see the 2 will have also same bits. Now I will come to 3. 3 is odd. So it will come here when n is equals to 3. I will do 3 by 2, right? For 3 by 2, I will get 1. So what I will do, whatever the result from 1, I will simply add 1. So by 1, I am getting 1. I will simply add 1. So it will become 2 for n is equals to 3. Right? Now, similarly, now n is equals to 4, it will come here. So I will do 4 by 2, and whatever the result of 2, 4 will have the same result. N is equals to 5, then 5 by 2, whatever the result of 2, I will simply add 1. So result of 2 is 1. I will simply add 1. 1 plus 1, it will be 2, and yeah, 5 will have. So simple. Now we can easily code it out, right? So these are the two approaches, and you can see we are getting an answer directly by solving. Basically, if we have stored our previous values, by taking the previous values, we are filling it. So the time complexity here will be big O of n, right? We are not taking any extra space or any. We are taking an extra space, but we are not taking basically any iteration for further. Okay. So space complexity will also be big O of n here, and that space complexity is for the output. That is same for the even the first approach, because in the first approach also we are filling the basically result array. So again, space complexity, if we are considering the output, it will be big O of n, and time complexity here it will be big O of n log n. So these are the two approaches that we have discussed so far. Okay, so in the next video I will give you a code implementation of these two approaches, and then we will simply move ahead, right? I guess if you want, we will give a quick dry run of this, and then we will simply move to the further more problems on bit manipulation. Okay, see you in the next video.